In this video, we're going to be talking about Chapter 10, Counting, for Math 142. In the previous section of Chapter 10, the previous videos, we talked about different ways to count how many ways a certain event could happen. So now we're going to lean back into what we remember about probability and use that counting to help us find probabilities. So for picking up where we left off, we are on problem number 15. So notice again, it says we're using combinations and permutations to find probabilities. Make sure, especially when you're looking at your homework and doing your quizzes and tests and things like that, that you're paying attention to what the question is asking for, whether it's asking just for you to count up how many ways to do a certain thing versus finding the probability. So you'll recall that probability is the number of ways a particular event can happen divided by all of the different possible outcomes in a particular situation. So all of these, since we're going to be looking at probabilities now, all of these are going to have division involved. So just as you've probably been doing for all of chapter 10, a calculator will definitely be handy for this. So let's look at number 15. And notice that we're going to give our answers as percents rounded to 4 decimal places. So 15 asks, what is the probability that if 6 letters are typed, no letters are repeated? Before I go through this problem, I want you to look at number 15 and carefully notice the difference in the wording. It's very important that you pay attention to the little detail here. So 15 says we're just typing letters. There's no kind of restriction or anything else, just typing 6 letters. When we look at that was in number 15. In number 16, 4 letters are typed, but we're going to put a restriction on that and say from the beginning, we cannot repeat. So that's an important note to think about as you look at these problems, because it's going to change the way we kind of put our numbers together here. So, what is the probability that if 6 letters are typed, none are repeated? So, what that tells us is that we can't have the same letter more than one time. So, the way that that could happen would be to start with our regular alphabet, which is 26 letters. We're going to have 26 to start with, and then 25, and then 24, 23, 22, and then 21. Now, notice that that's showing the non-repetition. That's dealing with this part here. But the total on the in the denominator is not going to take into account that kind of repetition idea. So repetition, it does not say can't happen. This is where this is a little bit tricky. So really pay attention to the wording difference between 15 and 16. In the beginning, this part here, there was no mention that repetition's not allowed. We just said, well, what if it just happens to occur that there is no repetition? So since in the beginning in the setup it didn't mention anything about repetition, we can assume that we still were able to repeat. We're just typing letters. There was nothing that said what we could and could not do in our typing. So down in the denominator, it's going to just be 26 times itself 6 times. You can give yourself a little bit of a shortcut there to use an exponent if you want to just write 26 to the sixth. So this would be approximately 0.5366045 and so on. We want to round to 4 decimal places here. So actually, let me put one more. I have one more digit I know that I'm going to put there is a 1. So when we move our decimal, we multiply by 100 to turn this into a percent. Then we still need 1, 2, 3, 4 decimal places after it. And remember, don't round until you've turned it into a percent. So our final answer there would be 53.660. And then that 4 is going to round up because it's followed by the 5. So we end up with 53.6605%. Let's look at number 16. So again, notice the subtle difference. 4 letters are typed without repetition. This first part kind of determines your denominator. Just like up here, that determined our denominator was 26 times 26 times 26 because it did not mention the inability to repeat. This one says we cannot repeat. So I'm actually going to start in the denominator this time. Since it says we cannot repeat, let's go ahead and think about what are all the possible words, quote unquote words that exist out there. with 4 letters if we can't repeat. So we know we'd start with 26, but then if we know we've been told ahead of time you can't repeat, then we're going to lose one option, one letter each time. So we're down to 26 times 25 times 24 times 23. Now up at the top, this second part is what determines our numerator. What is the probability that all 4 will be vowels? So again, you have to think about what are you choosing from here. We're only choosing from the vowels. So again, remember the American alphabet, which is what we tend to use in this class, has 26 letters. 5 of them are vowels, 6 are consonants. So we want all 4 of these to be vowels. So again, we think about starting with picking one vowel to start. So we have 5 to pick from. We know we're not allowed to repeat. So now we're down to 4, then 3, then 2. So this gives you a very, very small decimal value. This is approximately 0.0003344. We multiply by 100 and then count 1, 2, 3, 4 digits over. So our percent here, it's less than a percent. It's a very, very small amount here, is 0.0334%. That's why we usually will ask, or more will ask you to go out so far with our percents, because if we said round to the nearest percent even, you'd still be at 0 here. So we want to make sure we have something to look at. All right, let's look at number 17. 5 letters are typed with repetition allowed. So again, this is sort of our uh, what we know about what is allowed. That's going to kind of create our denominator or help us with our denominator. What's the probability that all 5 will be vowels? So since repetition is allowed, I'm going to go ahead and use exponents for this just to make it a little bit simpler since we're working with 5 letters here. So if repetition is allowed, then we know that we have all 26 letters available to us for each of the 5 letters we're going to type. So 26 to the 5th, and then in the numerator, same thing, 5 letters will all be vowels. There are 5 vowels. It could be A, right? Repetition is allowed. So we have all 5 vowels available to us for all 5 letters that we choose. So we have 5 to the 5th divided by 26 to the 5th. Again, we're going to get a pretty small decimal value here, 0.00026,301. If we multiply by 100, turn that into a percent, rounded to 4 decimal places, we're at 0.0263%. Now for problem number 18, these are all going to revolve around taking a multiple choice quiz with 5 questions. Each question has 4 possible answers. And I do want us to just assume here that for each question, there's just one right answer and then 3 wrong answers. So notice for part A, it's not a probability question, it's just a counting question. How many different ways are there to answer all of the questions? So think of each question as a task, right? So for the first question, so I'm going to list, we have 5 questions here. So 1, 2, 3, 4, 5. There are 5 questions, and we're going to multiply together. How many options do we have for each of those? Well, if you take a multiple choice quiz, the first question has 4 answer choices. Regardless of what you pick for that first one, you still have the same 4 and then 4 and then 4. So these are all going to be filled in with 4s, or we could have said 4 to the 5th, which is 1024. So now that's helpful because that's basically what we've done is we've found our denominator first. That is all. If you gave out 1024 different multiple choice quizzes with 5 questions with 4 possible answers, you could get every single one of those answer sheets would be different for 1024 of them. All right, so now we know that that is our denominator. We'll use those as we move into our probability questions. So if you randomly guess on all questions, what's the probability that you get them all correct? All right, so our denominator is 1024. We know that. That's all the different possible answer sheets that exist for this quiz. Now we're saying we want to get them all correct. So if we think back to what I mentioned at the beginning of the problem, how many answer choices are correct for each problem? well, we said there's just one right answer, three wrong answers. So this would be 1 times 1 times 1 times 1 times 1, or whoops, time, or 1 to the fifth. Uh, there's one choice that's the right choice for each of the questions. There are 5 questions. There we go. So we're at 1 over 1024. Again, we grab our calculators, turn that into a decimal, and then I'll just give our final percent here once we round it, 0.0977%. For C, again, we're going for a probability, so we know our denominator is 1024, or 4 to the fifth. This time it says we're randomly guessing what's the probability you get all of them wrong. So again, I mentioned before, we're working under the assumption that each question has 1 right and 3 wrong answers. So that means that there are 3 ways that you could answer each question incorrectly. So 3 to the fifth. Again, once we multiply out and then divide that up, turn it into a percent, we're going to get to 23.7305%. And then finally, for the last one down here, if you randomly guess on all questions, what's the probability you get the first 2 wrong and then the rest correct? So again, we're relying on that idea that there is 1 right, 3 wrong. So getting the first 2 wrong means that you picked one of the 3 wrong answers. And then the rest correct means that for the last 3 questions, you picked the 1 right answer. So we'd end up with 9 over 1024 there. And turning that into a percent, again, multiply it and then divide and then multiply by 100 to turn that into a percent. We end up with a percent of 0.8789%. I hope this video has been helpful for you.